We
All
are
right.
now live.
Hello, people.
Hello, world. Well, it's funny. People could literally watch this right now. Like if you post it on Facebook or something.
That'd be exciting, huh?
Because I think it creates a YouTube link right away.
It creates a live YouTube link. Yeah,
Yeah.
I've watched these before.
Wow.
Oh yeah, I've seen random stuff.
I don't think anyone would be excited to watch this conversation.
They can chat if they're watching live.
Most people will have no idea what we're talking about.
We talking about if you will.
Worksheet 37. Did anybody watch any of the videos about this? You did, Zach, right?
Yeah,
Yeah.
it is.
So, should I go over what a hash table is a little bit?
Bring up the worksheet. Or we.
Okay.
Well, let's jump into the code. I mean, video we can watch later.
Screen share. Let's do it.
Now we have a whiteboard.
What? Oh, I see. The idea of hashing, just briefly, is that for the first time we're using value pairs. We have a key and then the value, and the best analogy is like a dictionary, where you have a word and a definition. The word is the key, and the definition is the value. The code for hash tables deals with the key, and then afterwards associates it with the value. So. And it's still based on, at least the ones that they're showing us are based on arrays. That's what's underneath this dynamic.
I think they actually call it dictionary in Python, right?
Yes.
Makes sense.
So in almost every case that they use a hash table, it's used. In fact, I'm not sure you can use it any other way. It has to have a value and a key. That's how it works. So the first thing that happens is the key gets hashed, and that means that it gets converted into an integer, a unique integer. And so there's all kind of algorithms, and the one that they talk about in the reading and is a very simple one based on the alphabet, but in reality they're much more complex, I'm sure.
Wait,
So
should we share the doc in the chat? Because you're just showing your screen, but we can use it in Drive, right?
yeah, that'd be better.
Let me try to bring it up. Is it in the Drive?
Yeah.
Oh, one of you guys will have to do it unless I add myself.
I'm fine looking at his screen.
Okay.
But yeah, it'd be better if we can have it in Drive, I guess.
I thought it was in Drive.
It is, all of them are in Drive. In worksheets, same as worksheets. So one of the things that happens when you create hash tables is that there's a possibility of having two unique numbers refer to the same location, the same index in the array, and that's called a collision. And so they have to do tricks to prevent or deal with collisions. So the example they give is these a list of names that you see here. And that's basically what they're expressing here, is that what do you do when two hashtags send you to the same location in the index? Does that make sense?
Yeah, but isn't there a way to have an algorithm so that all indexes are unique?
Seems to me, Huari, I was thinking about that when I was reading this, that when we create MySQL databases, for example, and you auto-assign an index to each thing, that creates a unique index so that you don't get collisions, right? And it seems to me that almost any sophisticated hashing algorithm would keep things from colliding. You know, the example they give is really very simple, and probably not something you'd find used, I'm guessing.
Right. I think it might be because to create a unique one, the index might be extremely large or something. Right? Maybe that's the problem. They don't want to have a really large index because that would mean the array has to start really large when maybe, at the beginning there's only a few elements.
Right.
Using too much memory. Maybe that's the case. I don't know.
Yeah, I was thinking too, some of the hashtags they generate are 128 characters, 256 characters, and it could be unnecessarily unwieldy in terms of memory, I guess, if you did that.
Yeah.
We're on worksheet 37, right?
Yes.
Which one are you looking at? Because I see two that say worksheet 37 open addressing.
I used Google Doc versions. There's a PDF version.
Oh, I see.
I use the Google Doc ones.
Maybe cool to actually look up how some languages implement hashing, like, JavaScript or Ruby or something.
All right, I have it open in the drive in the...
Or Python.
Yeah, JavaScript in particular. I mean, because every time you see an associative array, that's what you're looking at. Is a key
JavaScript objects, yeah. All the objects are hashes, which is different than other languages, because other languages, they have objects are just objects. In JavaScript, objects are simply hashes, So, except that instead of storing only a certain type of variables in the hash, you can store objects in the object, which are variables are variables are data types. But you can store objects in the object for that particular key. You can store functions for that particular key. And,
would make sense though, because if we're storing a struct is only a small step really away from an object. It's the same concept,
Yeah, it's like the same concept, but I think in other languages it's more restricted. You can only store one type. At least in Python, I think they're all the same type, where you can't have a dictionary with some of its keys holding an object and then some other keys holding integer and strings. But I do want to know, like, how do they hash it, like the hashing algorithm. That's pretty interesting.
Yeah, I suspect this will show up again in operating systems, and other classes down the line. Hash tables. So anyway, that idea of collisions drives a lot of what happens in the design of hash tables. There's different ways of solving it, and that's what the worksheets were basically about, was a couple approaches at solving how you deal with more than one index sharing the same key. So first, you take the value and you hash it. And the open addressing, which is what this worksheet is about, the way that they solve it is they imagine all of the entries in an array like they show in this little table here. And as you walk down this array, when you hash it, you get an index, and that's where the value is supposed to be placed into the array. So if it has, let's say that it's supposed to go into this index here, right? if that one's already full, that's a collision. So it has to go and do what's called probing. And probing is continuing down the array to find the next open spot to be in.
And the two ways to resolve the collisions are the open and guessing, which would double the size of the array or something, right? And then also chaining.
Yeah, that's right. That's right.
Which I don't really understand chaining, but I'm sure we'll get to it.
I do a little better with chaining than I do with this stuff.
Yeah. I think chaining is actually simple.